Kimmer here. Today I want to talk to you for just a little bit about logical operators. And this is just a basic overview. I do cover quite a bit, but it is still pretty basic. So let's move forward. Okay, there are three types of logical operators in C that you can use. First, we're going to talk about the AND operator. Now the AND operator is actually two ampersands written together. So ampersands is the shift on the 7 key. That's where you can find it. Okay, and that means or, and that means and we'll talk a little bit more about what that means. Moving on to or would be the two pipes. Now, those are not L's, those are not ones, those are pipes. So it would be a shift on the backslash key. It's a straight up and down. Looks like it has a little space in there, but when you go ahead and type it, it won't be like that. So that would be your or operator. And the last one is the not operator, which you probably already seen when you did things like not equals. Okay, so that is the exclamation point. And the exclamation point can be found as a shift on the 1. Okay, so those are the three different types of logical operators that we can use. Now let's see how we use them. Let's take an expression here. You'll notice, let's say we want to give a scholarship to any students whose grade point average, or otherwise known as GPA, is greater than or equal to 3.0. And, notice the two ampersands, and the credits that they currently have total are less than 30. So you'll notice that we have two different expressions here, one being GPA greater than or equal to 3.0, and the other being credits less than 30. Now you'll notice that I have the and here. So now the entire thing is considered one big expression and has one big value, even though each of those green arrows has a separate little value. And that's going to bring us into something called truth tables. So you could have two expressions, expression 1 and expression 2. However, the entire thing has one single expression value of a Boolean value of true or false. So let's take a look at these truth tables. If the first expression is true and the second expression is true, then the entire expression is true. And this is in an and. Don't forget, that's what we're talking about is and. Let's take another example. What if the first one was true but the second one was false? In an and situation, then the entire expression would be false. Let's take a look at this. What if the first one was false but the second one was true? In an and situation, the entire expression value is false. We got one more combination to look at, and what if they're both false? Well, if they're both false, then the entire thing is false. So one thing I want you to realize, in an and situation, both expressions must be true in order for the whole thing to have a true value. Anything else is going to give it a false value. These are called truth tables. Now, let's go look at some truth tables for or situations. So you have, again, the same two expressions, but you have an or situation. So if the first expression is true, or the second expression is true, then the entire expression is true. What if the first expression is true, but the second expression is false? Well, because you're in an or situation, that means either or, then the entire thing is still true. What if the first one is false and the second one is true? Then again, it's an or situation, and we have the entire thing being true. So what if they're both false? In an or situation, remember, at least one expression must be true. So therefore, in this situation, they are both false. So remember, at least one expression must be true in order for the entire thing to be true. So let's go ahead and take a look at our example that we're using, our GPA of greater than 3.0 and credits of less than 30. Let's give it some values. Okay, let's assume that the GPA was 2.7 and credits are 22. If we make that assumption, the GPA of 2.7 is greater than or equal to 3.0, and that's false. If we also make the assumption that credits are 22 then it's less than 30. Well, that part's true. Now take a look at that. We have an and situation. So because we have an and situation, the first one is false, but the second one is true. But if you remember, in an and situation, they both have to be true. Therefore, this is false. Okay, so what if we have an or situation, right? Let's take a look at those. We have a GPA of 2.7, which makes the first thing false. And we have a credits of 22 still, which makes the second expression true. So what is the whole expression? Is the entire expression with an or situation going to be true or false? Hopefully you said true. Remember, with an or, only one of them has to be true to make the entire thing true. So what if we change the values of the GPA and the credits? Now look, we're looking at an or, and the GPA is 3.5. Can you tell if the entire expression is true or false without even knowing the credits? Think about that. The 3.5 is true, right? So the first one is true, but if it's an or situation, we don't need to know the credits. Think about it. The whole thing is true. Because it's an or, as long as one's true, the rest is true. This is called short circuit evaluation. For an or situation, you want to code the expression most likely to be true first, because the computer will actually just look at that. If it's true, it sees an or, it says, all right, I'm done. I don't even need to look at credits. Okay. What if this were an and situation? Can you still tell? Assume that the GPA is 3.5, but we don't know the credits yet. Do we know if this is going to be true or false? Well, with an and situation, right? With an and situation, we have the first one is true, but we still need to know the credits. Because this, with an and situation, both have to be true. So we're going to have to look at credits. So let's assume credits was 42. Is 42 less than 30? Nope, false. So because we have an and situation, right? The entire thing is going to be false. But what if the numbers for these change? Let's take a look at that for a second. Let's assume that the GPA is 2.9. So is 2.9 greater than or equal to 3.0? Nope. So the answer to that is false. But because it's an and situation, do you know the answer? Hopefully you said false without even looking at credits, without even knowing credits. It doesn't matter. Because in order for an and situation to be true, both have to be true. So if the first one is false, I don't even need to go any further. I know the whole thing's going to be false. So to do short circuit evaluation in an and situation, you're going to have to code the expression most likely to be false first. Because if it sees that it's false, then the whole thing is false. All right. There's one more thing we have to talk about. What if you have both? What if you have both ands and ors in the same expression? So you're asking about GPA greater than or equal to 3.0 and credits less than 30 or credits greater than 45. It makes a difference. Right now, the way it sits, okay, the computer will do ands over ors. So if you wanted it to do the and situation first, meaning it has to match both of those to be true, or credits can be greater than 45. So if we're looking at this, someone with a GPA of greater than or equal to 3.0 and less than 30 credits can make this true, or someone with greater than 45 credits regardless of their GPA. So they could have a 1.0 GPA, but as long as their credits are greater than 45, it would also make this true. So just remember this, A comes before O, meaning and comes before or. So it's always going to do the ands first. Now, what if we don't want that? What if we wanted a GPA of greater than or equal to 30 and either less than 30 credits or greater than 45 credits? Then we would have to use parentheses. So we can use parentheses to control what happens. In this case, just like in math and order of operations, it'll go through and figure out, okay, do they have less than 30 or greater than 45 credits? Because either of those would be okay. And as long as that's true, then, it would look to see their GPA. So parentheses control what happens. So I hope you enjoyed this little introduction to logical operators.